In 2025, Manaus remains one of the most isolated major cities on Earth, now home to over 2.4 million people, sitting in the heart of the Amazon, with no bridges crossing the mighty river and no continuous land route connecting it to Brazil's coast thousands of kilometers away. Yet from this unique urban outpost, researchers using LIDAR technology have discovered massive ancient cities hidden beneath the rainforest canopy, including the groundbreaking 2024 mapping of the Upano Valley that revealed settlements supporting tens of thousands of people over 2,500 years ago. These discoveries from Manaus are rewriting our understanding of what lies beneath the Amazon's green ceiling. But to grasp the true scale of what remains hidden, you first need to understand just how vast this rainforest really is. The Amazon's staggering 2025 scale. The Amazon rainforest stretches across 6 million square kilometers of South America in 2025, covering territory equivalent to roughly 3/4 the size of the contiguous United States. This massive green expanse dominates the northern half of South America, with Brazil containing approximately 60% of it within its borders, while Peru holds about 13%, Colombia 10%, and the remaining portions spread across Bolivia, Venezuela, Guyana, Suriname, French Guiana, and Ecuador. Despite occupying this enormous landmass, the entire Amazon region supports only about 30 million people as of 2025, creating one of the lowest population densities on Earth at roughly 5 people per square kilometer. This sparse population means the Amazon could theoretically fit the entire population of South Korea and still maintain lower density than most European countries. The population distribution reveals something remarkable about where people actually choose to live within this vast wilderness. Current satellite data shows that 78% of Amazon residents cluster within 50 kilometers of major rivers, leaving massive inland territories with population densities below 1 person per square kilometer. Some areas in the Brazilian states of Amazonas and Para record densities as low as 0.3 people per square kilometer, making them less populated than the Sahara Desert. This clustering effect means that roughly 4.2 million square kilometers of Amazon territory remain essentially uninhabited by permanent settlements. Modern satellite imagery from 2024 and early 2025 reveals the staggering scope of unexplored terrain that persists despite decades of technological advancement. The forest canopy creates an impenetrable barrier that conceals whatever lies beneath, and until the advent of LIDAR technology, most ground details remained completely hidden from view. Even with advanced imaging capabilities, researchers estimate that vast sections of the Amazon have never been systematically surveyed on the ground. The paradox becomes even more striking when considering the technological capabilities available in 2025. Satellites can now detect objects as small as 30 centimeters from space. Drones can penetrate forest canopies with specialized sensors, and GPS tracking allows precise navigation anywhere on Earth. Yet massive sections of the Amazon remain as mysterious and inaccessible as they were centuries ago. The forest itself acts as a natural shield, with triple-layer canopies blocking visibility, dense undergrowth preventing easy movement, and complex river systems creating natural barriers that modern technology struggles to overcome efficiently. This technological limitation has profound implications for understanding what the Amazon conceals. Ground-penetrating radar can only operate effectively when researchers can physically transport equipment to survey sites, but reaching many locations requires weeks of river travel, followed by days of hiking through unmarked terrain. Helicopter access remains limited by fuel capacity and landing zone availability, while fixed-wing aircraft cannot penetrate the canopy to deliver detailed surface information. The result is a situation where humanity possesses the technical ability to map distant planets more thoroughly than significant portions of our own rainforest. Recent data compilation projects have quantified exactly how much Amazon territory remains unmapped. The Brazilian National Institute for Space Research reported in late 2024 that approximately 2.1 million square kilometers of Amazon rainforest had never been surveyed by ground teams, while an additional 900,000 square kilometers had only been visited once or twice by researchers. These figures exclude areas that have been photographed from aircraft but never accessed on foot, which would push the unmapped total even higher. The transportation infrastructure that might enable deeper exploration remains virtually non-existent across vast Amazon regions. Only 12% of the Amazon basin currently has road access within 10 kilometers, and many of these roads become impassable during rainy seasons that can last up to 7 months annually. River transportation provides the primary access method for most areas, but the Amazon River system includes over 15,000 tributaries, many of which have never been fully navigated or mapped. This creates a situation where reaching unexplored areas often requires custom expedition planning that can take months to organize and execute. The challenging access conditions have inadvertently preserved whatever secrets lie hidden beneath the forest canopy. Archaeological sites that might have been discovered and potentially disturbed decades ago in more accessible regions remain untouched simply because no one can reach them easily. The same transportation barriers that frustrate modern researchers also protected ancient settlements, indigenous territories, and natural ecosystems from outside interference for centuries. What makes this situation particularly intriguing is that recent discoveries have emerged from areas that seemed completely inaccessible until new technologies made limited exploration possible. The most significant archaeological finds of 2024 occurred in regions that required helicopter access combined with specialized ground equipment, suggesting that the most important secrets may be concentrated in the most difficult places to reach. The clustering effect of major discoveries around specific access points creates an interesting geographic pattern. Most significant archaeological sites identified in recent years lie within 200 kilometers of either major urban centers or river confluences that allow boat access. This distribution suggests that vast interior regions, particularly those more than 300 kilometers from navigable waterways, remain almost completely unknown. These remote zones represent roughly 40% of the total Amazon area and could contain the largest concentrations of undiscovered sites. Current exploration efforts focus on establishing strategic base camps that can serve as launching points for deeper penetration into unmapped territories. The most ambitious projects planned for 2025 target areas that have never been visited by researchers, and they all depend on one crucial urban outpost that serves as the gateway to the Amazon's deepest mysteries, Manaus, the isolated metropolis in 2025. That outpost is Manaus, standing at the confluence of the Rio Negro and Solimões rivers as a sprawling urban island of concrete and steel completely surrounded by an unbroken sea of green rainforest canopy that extends to the horizon in every direction. This Brazilian metropolis now houses 2,434,640 residents as of 2025, making it the 7th largest city in Brazil despite sitting in one of the most remote locations imaginable for a major urban center. The city has grown by roughly 1.15% to 2.43 million people, adding thousands of new residents to an already crowded metropolitan area that exists hundreds of kilometers from the nearest comparable population center. The growth statistics become even more remarkable when you consider that Manaus sits roughly 1,500 kilometers from Sao Paulo and 1,700 kilometers from Rio de Janeiro with no direct road connections to either city. The nearest major urban area is Bogotá, Colombia, which lies about 1,100 kilometers to the northwest, while Lima, Peru sits approximately 1,400 kilometers to the southwest. This geographic isolation makes Manaus the most isolated major city in the Western Hemisphere, yet its population continues expanding at rates that exceed many coastal Brazilian cities with direct highway access to the rest of the country. The economic magnetism that draws people to this remote location stems largely from the Manaus Free Trade Zone, established in 1957 to encourage industrial development in the Amazon region. This special economic zone offers significant tax incentives that have attracted 600 companies to establish manufacturing operations in the city, creating 108,373 direct jobs, according to recent industrial statistics. Major global corporations operate large-scale production facilities in Manaus, manufacturing electronics, appliances, and consumer goods that serve both Brazilian and international markets. The city's industrial success creates a unique economic paradox, where multinational corporations transport raw materials thousands of kilometers into the Amazon, process them in modern factories, then ship finished products back out through the same complex logistics networks. This arrangement works because the tax advantages offset the substantial transportation costs. But it also means that Manaus depends entirely on maintaining reliable supply chains that stretch across vast distances. Components for electronics manufacturing arrive by cargo ship up the Amazon River from the Atlantic Ocean, while finished products often travel the same route in reverse, creating a constant flow of commercial traffic along the waterway. Daily life in Manaus operates under constraints that residents of most major cities never experience. Power generation depends on a combination of hydroelectric facilities along Amazon tributaries and thermal plants that burn fuel transported upriver, while water treatment systems process river water that flows from across the entire Amazon basin. The city's infrastructure must account for seasonal variations in river levels that affect everything from port operations to waste management systems. The city serves as the primary staging ground for virtually all serious Amazon research and exploration activities. Scientific expeditions planning to penetrate deep into the rainforest typically spend weeks in Manaus organizing equipment, hiring local guides, and coordinating with research institutions based in the city. The Brazilian National Institute for Space Research operates a major facility here that processes satellite data covering the entire Amazon region, while international organizations maintain permanent offices to support ongoing conservation and archaeological projects. This concentration of expertise and infrastructure makes Manaus indispensable for researchers attempting to access remote areas of the rainforest. Recent archaeological discoveries that have captured international attention originated from expeditions launched from Manaus. The city's port facilities allow researchers to load specialized equipment onto boats that can navigate smaller tributaries, while the local airport handles helicopter transport to sites that boats cannot reach. Storage facilities in Manaus house artifacts and specimens collected from across the Amazon, and laboratories here process initial analyses before shipping samples to universities worldwide. Without this urban infrastructure, most significant Amazon discoveries of the past decade would have been impossible to achieve. The transportation networks that connect Manaus to the outside world reveal both the city's importance and its vulnerability. Commercial flights link Manaus to major Brazilian cities multiple times daily, but weather disruptions can easily ground air traffic for days at a time. River transport remains the primary method for moving heavy cargo, but seasonal water level changes affect navigation schedules throughout the year. During dry seasons, larger vessels cannot reach the city's main port facilities, while flood seasons can make river navigation dangerous due to increased current speeds and floating debris. Supply chain disruptions that would merely inconvenience other cities can create serious shortages in Manaus. When river levels drop below critical thresholds, fuel shipments may be delayed for weeks, affecting everything from power generation to transportation within the city. Food distribution networks that depend on refrigerated transport face particular challenges during the rainy season when connections to agricultural areas become unreliable. The city's role as a gateway to Amazon secrets extends beyond scientific research to include ecotourism, indigenous community liaison work, and environmental monitoring programs. Tour operators based in Manaus organize expeditions to remote areas where visitors can observe wildlife and traditional communities, while environmental agencies coordinate forest protection efforts across multiple countries from offices here. Government agencies responsible for indigenous affairs maintain regional headquarters in Manaus, facilitating communication with communities scattered across territories larger than many European countries. Manaus represents humanity's most ambitious attempt to establish a major urban center in the heart of Earth's largest rainforest, demonstrating that modern technology and economic incentives can support millions of people in locations that seemed impossible for large-scale settlement just decades ago. Yet maintaining this urban success requires overcoming transportation challenges that would test even the most advanced logistics systems. And these same barriers that make daily life complicated also determine which Amazon secrets remain accessible to discovery. The transportation maze of 2025. Getting to Manaus in 2025 still means navigating one of the most complex and unreliable transportation networks on Earth, where a journey that should take hours can stretch into days or weeks, depending on weather conditions, river levels, and the seasonal whims of an untamed wilderness. Despite decades of promises and billions of reais in proposed infrastructure spending, the fundamental challenges of moving people and cargo through the Amazon remain largely unchanged from previous decades. Brazilian Highway 319 continues to serve as a major overland route connecting Manaus to the rest of Brazil, but significant portions of this 900-kilometer road remain unpaved as of early 2025. The Brazilian Senate approved legislation in late 2024 that weakens federal environmental licensing powers, potentially clearing the way for complete paving of BR 319 by streamlining the approval process from 3 bureaucratic steps to 1. However, environmental groups have mounted fierce opposition to this project, arguing that full paving will trigger massive deforestation in pristine rainforest areas that currently remain untouched precisely because the road access is so difficult. The political battle over BR 319 has delayed construction work that was originally scheduled to begin in 2024, leaving hundreds of kilometers of the route in the same muddy, seasonal condition that has frustrated travelers for decades. During the dry season from June through November, the unpaved sections become dusty obstacle courses lined with deep ruts and washboard surfaces that can destroy vehicle suspensions. When the rains arrive, these same stretches transform into impassable mud bogs where vehicles regularly become stuck for days while waiting for conditions to improve or help to arrive. Even when travelers successfully navigate the highway system, they still face the reality that the Amazon River system lacks a single bridge crossing along its entire 6,400-kilometer length, forcing all ground transportation to rely on ferry services that operate on schedules dictated by river conditions rather than passenger convenience. Ferry crossings at key points along the transportation network can involve waits of several hours during peak travel periods, while mechanical breakdowns or severe weather can shut down ferry operations entirely for days at a time. The ferries themselves range from modern car-carrying vessels to small motorboat operations that can handle only a few vehicles per crossing, creating bottlenecks that ripple throughout the entire regional transportation system. River transportation remains the backbone of Amazon logistics, with the Amazon River navigable by ocean-going vessels for roughly 2/3 of its length from the Atlantic Ocean to Manaus. This waterway supports everything from massive cargo ships delivering manufactured goods to floating gas stations and convenience stores that cater to the constant boat traffic. However, seasonal water level variations create their own set of challenges that affect everything from cargo delivery to scientific expeditions. During peak flood season from December through April, many tributaries become too dangerous to navigate safely due to increased current speeds and floating debris, while the dry season from August through October can lower water levels enough to ground larger vessels entirely. Research expeditions attempting to reach remote archaeological sites face logistical nightmares that can consume months of planning and tens of thousands of dollars in transportation costs alone. A typical expedition to an unexplored area might require chartering a cargo plane to fly equipment to a remote airstrip, then transferring gear to helicopters for transport to a river access point, followed by days of boat travel upstream to reach base camp locations. Weather delays can strand research teams for weeks at remote sites when scheduled pickup flights cannot operate, while equipment failures in the field often mean abandoning expensive scientific instruments because retrieval costs exceed replacement costs. Small aircraft and helicopter access has enabled virtually every major Amazon discovery of the past 5 years, but this transportation method brings its own constraints that shape what can be found and studied. Helicopter fuel capacity limits operating ranges to roughly 300 kilometers from established fuel depots, while landing zone requirements restrict access to areas with suitable clearings or riverbank access points. Fixed-wing aircraft require prepared airstrips that exist in only a handful of locations throughout the vast Amazon region, concentrating exploration activities around these limited access points. The economics of helicopter transportation create a situation where research expeditions must achieve significant results quickly to justify operational costs that can exceed $15,000 per day. This time pressure often forces researchers to focus on sites that show immediate promise, rather than conducting the systematic surveys that might reveal less obvious archaeological features. These transportation limitations have inadvertently created some of the best protection for undiscovered archaeological sites throughout the Amazon region. Areas that would have been thoroughly explored and potentially disturbed decades ago in more accessible regions remain completely untouched, simply because the cost and complexity of reaching them exceeds the resources available to most research projects. The same geographic barriers that frustrate modern transportation also prevented historical looting or development that destroyed archaeological sites in other parts of South America, preserving ancient mysteries in locations where conventional access remains nearly impossible to establish. Yet recent technological advances have begun to overcome these transportation barriers in ways that seemed impossible just a few years ago, revealing secrets that had remained hidden beneath the forest canopy for centuries. LIDAR revolution, seeing through the canopy. The breakthrough came when recent advances in the 2020s revolutionized archaeological mapping through aircraft-mounted laser scanners that could penetrate the Amazon's triple-layer forest canopy and map the ground surface beneath with unprecedented precision. LIDAR technology fires millions of laser pulses per second downward from aircraft flying at altitudes between 500 and 2,000 meters above the forest. These laser beams slice through gaps in the vegetation and bounce back to sensors that measure the exact time it takes for each pulse to return, creating detailed three-dimensional maps of terrain features that remain completely invisible from above. The technology can distinguish between laser reflections from treetops, middle canopy layers, and the actual ground surface, effectively removing the forest digitally to reveal whatever lies beneath. The laser scanning process generates detailed topographical maps showing elevation changes as small as 10 centimeters. This level of precision allows researchers to identify artificial structures like ancient roads, building foundations, agricultural terraces, and ceremonial platforms that appear as subtle variations in ground elevation. Features that would be completely invisible to researchers walking through dense forest become clearly visible in LIDAR data as geometric patterns that stand out against the natural randomness of forest floor topography. Major LIDAR mapping projects completed in 2024 covered approximately 45,000 square kilometers of previously unmapped Amazon territory across Brazil, Peru, Ecuador, and Bolivia. The Brazilian Amazon LIDAR Initiative, funded jointly by the Brazilian government and international research institutions, completed high-resolution surveys of 23,000 square kilometers in Para and Amazonas states during the 2024 dry season. These surveys targeted areas identified through satellite imagery analysis as having potential archaeological significance based on subtle vegetation patterns and geometric clearings visible from space. The Ecuador Amazon Archaeological Project completed LIDAR mapping of 12,000 square kilometers in the Upano Valley region during late 2024, revealing what researchers describe as the most extensive pre-Columbian settlement network ever discovered in the Amazon basin. The survey identified more than 6,000 individual structures organized into at least 15 major urban centers, connected by a road network spanning over 300 kilometers. Initial ground truthing expeditions confirmed that many of these structures represent sophisticated architectural achievements, including residential complexes, ceremonial platforms, and agricultural infrastructure that supported populations far larger than previously thought possible in rainforest environments. The Peru Amazon Heritage Survey mapped 8,000 square kilometers along the Ucayali River watershed in early 2025, uncovering evidence of at least 2,400 previously unknown earthwork constructions. These include geometric earthworks, similar to those found in Bolivia's Llanos de Mojos region, suggesting that complex societies develop sophisticated landscape modification techniques across vast areas of the Amazon basin. The survey data indicates that many of these earthworks were connected by elevated roadways that remained functional during seasonal flooding, demonstrating advanced engineering capabilities that allowed year-round transportation across challenging terrain. LIDAR surveys revealed thousands of hidden sites across multiple countries, fundamentally changing our understanding of Amazon archaeology. The Upano Valley discoveries alone revealed urban planning on a scale that rivals Maya cities in Mexico and Guatemala, with residential areas, public plazas, and monumental architecture organized according to sophisticated design principles that maximized both defensive capabilities and agricultural productivity. The scale of these discoveries has forced archaeologists to completely revise their estimates of pre-Columbian Amazon populations. Evidence from LIDAR surveys suggests that the Upano Valley settlements supported populations of at least 100,000 people during their peak occupation period between 500 BCE and 300 CE. When combined with similar discoveries in Bolivia, Brazil, and Peru, current data indicates that the Amazon basin may have supported total populations exceeding 8 million people during pre-Columbian times, making it one of the most densely populated regions in the pre-contact Americas. The race to complete LIDAR mapping has intensified as deforestation rates accelerate across the Amazon region. Surveys must be completed before forest clearing exposes archaeological sites to destruction from agricultural development, mining operations, or infrastructure construction. The Brazilian government reports that 11,568 square kilometers of Amazon rainforest were cleared in 2024, with much of this deforestation occurring in areas that have never been surveyed for archaeological resources. Research teams estimate that deforestation destroys approximately 50 previously unknown archaeological sites every month, creating urgent pressure to complete surveys before these cultural heritage resources disappear forever. Current LIDAR technology faces significant technical challenges that limit survey coverage and increase operational costs. Aircraft must fly multiple overlapping flight paths to ensure complete coverage of target areas, with each flight path covering only 2 to 3 kilometers of ground width. Weather conditions affect survey quality, as cloud cover and precipitation can interfere with laser penetration, while wind speeds above 25 kilometers per hour make precise aircraft navigation difficult. The financial costs of LIDAR surveys create additional constraints on research coverage. Typical survey costs range from $400 to $800 per square kilometer, depending on terrain difficulty and required data resolution. The Ecuador Upano Valley survey required approximately $2.8 million in funding to complete, while the larger Brazilian Amazon initiative consumed over $12 million in government and international funding. Data analysis from completed surveys indicates that current discoveries represent only a small fraction of the archaeological resources that remain hidden beneath the Amazon's forest canopy. Statistical models based on site density patterns suggest that the Amazon basin contains at least 100,000 significant archaeological sites, with fewer than 3,000 currently known to researchers. These projections indicate that decades of additional LIDAR mapping will be required to document the full extent of pre-Columbian civilization in the Amazon rainforest. But the discoveries already emerging from this technology have begun to reveal ancient civilizations whose sophistication exceeded anything researchers had imagined. The 2024 to 2025 discoveries. The most dramatic example emerged from Ecuador's Upano Valley, where Stephen Roston and his team published discoveries in January 2020 that completely shattered everything archaeologists thought they knew about ancient Amazon civilizations. Their findings revealed a massive urban network spanning 300 square kilometers, with over 6,000 individual structures organized into what can only be described as ancient cities. These settlements existed between 500 BCE and 600 CE, making them roughly 2,500 years old and contemporary with the height of the Roman Empire. Yet they developed independently in the heart of the Amazon rainforest, using completely different architectural and urban planning approaches than anything seen in the classical world. The Upano Valley network consisted of 5 major settlements and 10 smaller ones connected by an extensive road system that included perfectly straight routes running for more than 25 kilometers across challenging rainforest terrain. The engineering required to construct these roads with direct right angles through dense forest demonstrates sophisticated surveying and construction capabilities that archaeologists previously assumed were impossible in Amazon environments. The roads connected residential neighborhoods within each settlement and linked the entire network into a unified transportation system that allowed efficient movement of people and goods across the region. Each major settlement was densely packed with rectangular platforms arranged around central plazas that served as focal points for community activities and ceremonies. The largest ceremonial platform discovered measures 140 meters by 40 meters and rises 5 meters above the surrounding ground level, representing a massive construction project that would have required coordinating hundreds of workers and moving thousands of cubic meters of earth and building materials. This central platform likely supported wooden buildings used for religious ceremonies or administrative functions, though the structures themselves decomposed centuries ago, leaving only the earthen foundations visible to modern researchers. The residential areas surrounding these ceremonial centers contained thousands of house platforms that supported substantial urban populations at the civilization's peak. The density of residential construction indicates that the Upano Valley supported urban population concentrations that rivaled major cities elsewhere in the ancient world, despite being located in what many researchers considered unsuitable terrain for large-scale urban development. Archaeological evidence suggests that some residential areas maintain significant population densities, requiring sophisticated systems for food production, water management, and waste disposal. The agricultural infrastructure that supported these urban populations included extensive field systems, drainage canals, and hillside terraces that maximized food production while managing seasonal flooding and drainage challenges. The field systems covered thousands of hectares and were organized in rectangular plots that show clear evidence of systematic crop rotation and soil management practices. Drainage canals channeled excess water away from residential areas during flood seasons, while directing irrigation water to agricultural fields during dry periods, demonstrating advanced understanding of hydrology and water management engineering. Defensive earthworks protected many settlements from external threats, indicating that these communities faced military challenges that required coordinated defense strategies. The defensive systems included ditches, embankments, and strategic choke points that controlled access to urban centers and agricultural areas. Some defensive installations protected road networks and river crossing points, suggesting that the Upano Valley civilization engaged in systematic territorial control that extended beyond individual settlements to encompass the entire regional network. The artifacts recovered from initial excavations have forced archaeologists to completely revise their theories about Amazon technological capabilities and cultural sophistication. Ceramic vessels show advanced decorative techniques and standardized production methods that indicate specialized craft workshops supplied goods throughout the regional network. Stone tools demonstrate sophisticated manufacturing techniques adapted specifically for rainforest environments, while organic artifacts preserved in waterlogged conditions reveal advanced textile production and woodworking capabilities that left no trace in drier archaeological sites. Carbon dating and stratigraphic analysis confirm that the Upano Valley civilization operated continuously for over 1,000 years before being abandoned around 600 CE, roughly 900 years before European contact with South America. The reasons for abandonment remain unclear, but archaeological evidence suggests that the settlements were gradually vacated rather than destroyed by warfare or natural disasters. Climate data indicates that the abandonment period coincided with regional drought conditions that may have disrupted the agricultural systems that supported the urban populations. Current excavation efforts face urgent time pressures as agricultural expansion and infrastructure development threaten to destroy undiscovered sites before they can be properly studied. Deforestation rates in Ecuador's Amazon region accelerated in 2024, with cattle ranching and palm oil plantations, expanding into areas that satellite analysis indicates contain additional archaeological sites. Research teams estimate that approximately 12 previously unknown settlement sites in the broader Upano Valley region remain unexcavated and face potential destruction within the next 5 years without immediate protection measures. Statistical projections based on site density patterns observed in surveyed areas suggest that the Amazon basin contains at least 50,000 additional archaeological sites of similar significance that remain completely unknown to modern researchers. These projections indicate that the Upano Valley discoveries represent only the beginning of what may become the most significant archaeological revolution in South American prehistory, fundamentally changing our understanding of human civilization's relationship with rainforest environments and revealing the true extent of indigenous technological and social achievements in the Amazon region. Yet understanding these ancient achievements requires examining the communities that have maintained continuous connections to this landscape across the centuries. Indigenous communities, the 2025 census. The Amazon basin supports over 30 million people from 350 different ethnic groups, with indigenous communities representing a crucial 9% of this total population, while occupying 3,344 formally recognized territories that collectively cover approximately 1.15 million square kilometers of Amazon rainforest. These indigenous lands constitute one of the most significant factors in forest preservation across the entire basin, with communities maintaining traditional practices that have sustained their populations for thousands of years while protecting vast areas from deforestation and development. Many indigenous communities continue practicing sophisticated agroforestry systems that maintain forest cover while producing diverse food crops through methods refined over millennia. The Kayapó people of Brazil maintain forest gardens that contain over 250 useful plant species arranged in complex polyculture systems that mimic natural forest structure, while providing medicine, food, and materials for daily life. These traditional agricultural practices often create distinctive vegetation patterns that appear in satellite imagery as geometric clearings or unusual forest compositions, leading researchers to investigate areas where they subsequently discover archaeological sites that indigenous oral histories had preserved knowledge about for generations. Approximately 100 indigenous groups comprising roughly 10,000 people maintain little or no contact with outside civilization, representing the largest concentration of uncontacted peoples anywhere in the world. These populations deliberately avoid contact with outsiders due to historical experiences of violence, disease, and cultural destruction that occurred during previous contact periods, particularly during the rubber boom era of the late 19th and early 20th centuries. Brazil's National Indigenous Peoples Foundation monitors the highest concentration of uncontacted groups, implementing strict non-contact policies unless the communities themselves initiate interaction. Indigenous knowledge has proven invaluable for guiding researchers to significant archaeological discoveries throughout the Amazon region, with traditional oral histories providing precise location information for ancient settlements that would otherwise require years of systematic survey work to locate. The Kichwa communities of Ecuador's Pastaza province directed researchers to several of the earthwork sites later, confirmed through LIDAR mapping in the Upano Valley, while Shipibo guides in Peru have led archaeologists to previously unknown ceramic production sites and ancient ceremonial centers along tributaries of the Ucayali River. These collaborations demonstrate that indigenous communities maintain detailed knowledge of archaeological sites for centuries through oral traditions that preserved information about ancient settlements, burial grounds, and ceremonial locations with remarkable accuracy. External pressures facing indigenous communities have intensified significantly in recent years as infrastructure development, mining operations, and agricultural expansion encroach on traditional territories at accelerating rates. Illegal gold. Mining activities in indigenous territories increased by 23% between 2023 and 2024 according to monitoring data from the Amazon Conservation Association, while cattle ranching operations expanded into protected indigenous lands by approximately 47,000 hectares during the same period. These incursions often involve armed conflicts between indigenous communities and outside economic interests, with 34 indigenous leaders killed in 2024 while defending their territories from illegal occupation or resource extraction activities. Several indigenous groups have established formal partnerships with conservation organizations and research institutions to document traditional ecological knowledge while protecting their territories from external threats. The Suruway people of Rondônia, Brazil partnered with Google Earth to create detailed maps of their territory that monitor deforestation and illegal activities in real time, while also documenting traditional plant knowledge that has contributed to pharmaceutical research. The Achua communities of Ecuador and Peru have collaborated with archaeological teams to establish protective zones around significant cultural sites within their territories, preventing looting and ensuring that scientific research respects traditional cultural protocols. Indigenous territories serve as crucial buffers, protecting both known and undiscovered archaeological sites from destruction through deforestation, mining, or agricultural development. Satellite analysis indicates that deforestation rates within indigenous territories remain 2.8 times lower than in surrounding areas, effectively preserving archaeological sites that exist within these protected zones. The Xingu Indigenous Territory in Brazil contains an estimated 1,200 previously unknown archaeological sites based on surface surveys conducted in collaboration with indigenous communities, while similar site densities within other indigenous territories suggest that these lands protect tens of thousands of undiscovered archaeological features throughout the Amazon basin. Oral histories maintained by indigenous communities contain detailed information about ancient settlements, migration routes, and ceremonial sites that may guide future archaeological discoveries in previously unexplored areas. The Huniquim people of western Brazil maintain traditional songs that describe ancient cities along major rivers, while Tucuna oral traditions include detailed descriptions of earthwork construction techniques that match archaeological evidence from recently discovered sites. These oral traditions often include precise geographic references to landscape features that allow researchers to identify specific areas where archaeological investigation should be concentrated. Policy changes affecting indigenous rights and land protection have created both opportunities and challenges for communities seeking to maintain traditional ways of life while protecting archaeological heritage. Brazil's new Constitutional Amendment 23, ratified in late 2024, strengthened legal protections for indigenous territories by requiring congressional approval for any reduction in protected area boundaries, while also establishing indigenous communities as co-managers of archaeological resources within their territories. Similar policy developments in Colombia and Peru have recognized indigenous communities as partners in archaeological research rather than obstacles to scientific investigation. Indigenous communities represent living connections to the Amazon's hidden past through cultural traditions, ecological knowledge, and oral histories that span thousands of years of continuous occupation in rainforest environments. However, their ability to maintain these traditional practices and protect archaeological sites faces unprecedented challenges as environmental pressures transform the Amazon landscape in ways that threaten both ancient heritage and contemporary survival. Climate change impact, the 2025 reality. The environmental forces reshaping the Amazon have accelerated dramatically by 2025. Creating conditions that simultaneously reveal archaeological treasures while threatening to destroy them before researchers can document their significance. Climate change has transformed the rainforest into a dramatically different landscape, with severe droughts becoming increasingly frequent and intense compared to historical patterns. The region experienced major drought events in 2005, 2010, and 2021, with scientists identifying 2021 as a potential tipping point when parts of the Amazon began releasing more carbon than they absorbed, fundamentally altering the forest's role in global climate regulation. These extreme weather events have created unprecedented challenges for archaeological research throughout the basin. Extended drought periods have lowered water levels in rivers and lakes, exposing areas that remained inaccessible during normal seasonal cycles and creating new opportunities for site discovery. However, The same conditions that reveal previously hidden locations also threaten to destroy organic artifacts and archaeological contexts that depend on consistent moisture levels for preservation. Sites that survived for centuries under stable environmental conditions now face rapid deterioration when exposed to extreme temperature fluctuations and prolonged dry periods. Deforestation patterns across the Amazon basin reflect the complex interplay between conservation efforts and development pressures that continue reshaping the landscape. Brazil has lost approximately 20% of its original Amazon forest cover, with an additional 6% showing significant degradation from logging, fire damage, and fragmentation effects. These statistics represent the cumulative impact of decades of forest conversion, but the rate of loss varies dramatically across different regions and time periods. Some areas have achieved significant conservation successes through protected area designation and indigenous territory recognition, while other regions continue experiencing rapid forest clearing driven by agricultural expansion and infrastructure development. The race between archaeological discovery and site destruction has intensified as researchers recognize that environmental changes are eliminating irreplaceable cultural heritage at an accelerating pace. Every month brings reports of newly discovered earthworks, ceramic scatters, and settlement areas that face immediate threats from cattle ranching expansion, soybean cultivation, or infrastructure development. Teams estimate that approximately 50 significant archaeological sites disappear each month due to deforestation activities, often before researchers even know they existed. The window for documenting these sites continues shrinking as agricultural commodity prices drive further forest conversion, while funding for emergency archaeological surveys cannot keep pace with the rate of site exposure and destruction. Changing precipitation patterns have fundamentally altered how researchers can access remote areas where the most significant archaeological sites likely remain hidden. Traditional navigation routes that riverboat captains have used for generations became unreliable as water levels fluctuate beyond historical ranges, creating new obstacles and eliminating familiar channels. Research expeditions planning to access remote areas now face completely different logistical challenges as waterways require smaller boats, longer travel times, and entirely revised supply chain strategies. These access difficulties particularly affect areas where the largest concentrations of undiscovered sites are likely located, creating a situation where the most important archaeological resources become increasingly difficult to reach just as environmental pressures threaten their preservation. Indigenous communities throughout the Amazon region have experienced severe disruptions to their traditional territories and cultural practices as climate change alters the environmental conditions that sustain their societies for millennia. Fishing communities along major rivers faced food security challenges when altered water levels eliminated traditional fishing grounds and forced families to relocate to areas with reliable water access. Agricultural cycles that indigenous groups have followed for generations no longer align with changing precipitation patterns, forcing communities to adapt planting schedules and crop selections that their ancestors developed over centuries. Many communities report that traditional ecological knowledge accumulated over generations no longer provides reliable guidance for predicting weather patterns or managing natural resources in their territories. Environmental changes have created unprecedented urgency for current research efforts, as scientists recognize that they may be witnessing the last opportunity to document many archaeological sites before climate impacts destroy them permanently. Research funding agencies have responded by prioritizing emergency documentation projects that focus on sites facing immediate environmental threats, but available resources remain inadequate for the scale of the challenge. The Brazilian National Council for Scientific and Technological Development allocated emergency funding for rapid archaeological assessment projects in 2024, but researchers estimate that hundreds of additional sites require immediate attention to prevent total loss of cultural heritage information. Conservation efforts have achieved mixed results in protecting undiscovered areas from the combined threats of climate change and human development pressures. Indigenous territories continue showing much lower deforestation rates than surrounding areas, with forest loss occurring 2.8 times more slowly within indigenous lands compared to unprotected regions. However, even these protected areas face increasing pressure from illegal activities, including gold mining, logging, and cattle ranching that have intensified as economic pressures increase throughout the region. Enforcement agencies report that illegal activities within protected areas increased significantly in recent years, while budget constraints limit their ability to maintain effective protection of remote territories. The sobering reality facing Amazon research is that environmental forces are simultaneously revealing the rainforest's hidden secrets and threatening to destroy them before their significance can be fully understood. Yet these same environmental pressures that endanger archaeological sites have also created conditions that allow researchers to discover forms of life that remained completely unknown to science until very recently. New species, the 2024 to 2025 catalog. Scientists describe new Amazon species almost every day, with discoveries that continue challenging fundamental assumptions about rainforest biodiversity and evolutionary relationships. The most remarkable recent find emerged in January 2024, when researchers confirmed a new species of northern green anaconda through genetic analysis, revealing that what scientists had assumed was a single anaconda species actually represents multiple distinct evolutionary lineages separated by millions of years of independent development. This discovery occurred when indigenous guides noticed behavioral differences in anacondas they encountered during traditional activities, leading researchers to collect tissue samples that revealed the genetic divergence. The pace of species identification has accelerated dramatically as research teams gain access to previously unexplored areas through improved transportation and detection technologies. Field researchers consistently encounter potentially new species during expedition periods in remote areas, with formal scientific descriptions representing only a fraction of the discoveries awaiting detailed study and classification. The Brazilian National Institute of Amazonian Research estimates that approximately 60% of Amazon tree species have never been properly cataloged, while the number of undiscovered insect, bird, reptile, and mammal species remains completely unknown. Recent discoveries demonstrate the extraordinary diversity that persists in isolated Amazon ecosystems. A bright red blind fish species discovered in 2007 represents just one example of the unique adaptations that evolved in specific microenvironments throughout the rainforest. The red-striped monkey found in 2015 highlighted how even relatively large mammal species can remain unknown to science for decades, while discoveries like the bald parrot from 1999 show that distinctive bird species continue emerging from areas that seemed thoroughly studied. These findings illustrate the ongoing surprises in Amazon biodiversity, with each expedition to unexplored areas yielding species that exist nowhere else on Earth. Ecosystems that have remained completely isolated from human contact continue producing species that challenge current biological understanding. The most pristine areas, typically located more than 200 kilometers from any road access and protected by difficult river navigation, harbor species assemblages that show no evidence of outside genetic influence. These isolated populations often display extreme adaptations to specific environmental conditions, such as fish species that survive in highly acidic water that would kill related species from other regions, or amphibians that complete their entire life cycles within single plant species. Species discoveries frequently occur in the same areas where archaeological teams subsequently identify ancient settlement sites, creating patterns that suggest indigenous communities historically chose locations with exceptional biodiversity for their permanent settlements. The Upano Valley archaeological discoveries occurred in areas where biologists had previously documented unusually high concentrations of endemic species, while ceramic workshops found along major rivers coincide with stretches that support unique fish assemblages. This correlation indicates that ancient peoples possessed sophisticated understanding of local ecosystems and deliberately established communities in areas with maximum biological resources. Environmental DNA sampling has revolutionized species detection by allowing researchers to identify species presence from water samples, soil cores, and air samples without directly observing individual animals. Teams collecting water samples from previously unstudied tributaries reveal genetic signatures from thousands of vertebrate species, including many that do not match any known species in existing databases. This technique proves particularly effective for detecting elusive species that avoid human contact, nocturnal species that remain hidden during daylight surveys, and aquatic species that inhabit deep water or complex root systems where traditional collection methods fail. Indigenous communities have guided scientists to new species discoveries through traditional ecological knowledge that includes detailed understanding of animal behavior, habitat preferences, and seasonal patterns accumulated over generations. Kayapo hunters directed researchers to previously unknown primate species by describing specific vocalizations and territorial behaviors that differed from familiar species, while traditional fishermen identified numerous fish species that formal scientific surveys had never documented. Traditional names for animals often indicate species distinctions that Western taxonomy has not yet recognized, leading to discoveries when researchers investigate indigenous classification systems. The species that remain undiscovered in unexplored Amazon regions likely number in the tens of thousands based on statistical projections from surveyed areas. Remote tributaries that have never been surveyed by biologists probably contain entire groups of fish, amphibians, and reptiles that exist nowhere else, while isolated areas within the Amazon basin may harbor mammal and bird species that evolved in complete isolation from their nearest relatives. Current estimates suggest the Amazon basin contains between 400,000 and 1.2 million species that remain completely unknown to modern biology, representing the largest reservoir of undiscovered biodiversity anywhere on Earth. Conservation implications of new species discoveries create urgent pressures for habitat protection as researchers realize that many newly identified species occupy extremely limited ranges that face immediate threats from deforestation and infrastructure development. Similar range restrictions affect most newly discovered species, making them extremely vulnerable to extinction before researchers can complete basic biological studies. The race between species discovery and habitat destruction has intensified as environmental changes eliminate irreplaceable biological diversity at accelerating rates. The Amazon's biological secrets extend far beyond what researchers can observe from the surface, with entire ecosystems existing in environments that remain completely hidden from conventional survey methods and may harbor life forms that have evolved underground in isolation for millions of years. Tunnels. These hidden biological treasures exist not only in the forest canopy and river systems, but also in the advanced technology now monitoring the Amazon from space. The satellite technology orbiting above the Amazon rainforest in 2025 represents the most advanced Earth observation capabilities ever deployed for archaeological research, with imaging systems that can detect ground features as small as 30 centimeters across, while penetrating atmospheric conditions that previously made consistent monitoring impossible. The resolution capabilities of current satellite constellations have transformed how researchers identify potential archaeological sites across the vast Amazon basin. Commercial satellite operators, including Planet Labs, Maxar Technologies, and the European Space Agency's Sentinel program, provide daily coverage of the entire Amazon region with pixel resolutions that reveal individual trees, small clearings, and geometric patterns that indicate human modification of the landscape. These imaging systems operate across multiple spectral bands, including visible light, near-infrared, and synthetic aperture radar that can penetrate cloud cover and vegetation to detect subsurface features that remain invisible to conventional photography. The breakthrough discoveries enabled by improved satellite technology have revolutionized archaeological site identification throughout 2024 and early 2025. Researchers analyzing satellite imagery identified over 3,400 potential archaeological sites across the Amazon basin during 2024 alone, with geometric earthworks, settlement patterns, and ancient road networks becoming visible through subtle vegetation differences and soil composition variations that appear in high-resolution spectral analysis. The most significant discoveries occurred when researchers combined multiple satellite data sources to create composite images that revealed landscape modifications spanning hundreds of square kilometers, including the road networks connecting Upano Valley settlements that remained invisible until satellite analysis revealed their geometric precision across dense forest terrain. Machine learning algorithms now process satellite imagery at unprecedented scales, analyzing millions of square kilometers of Amazon territory to identify patterns that human researchers would require decades to detect manually. These artificial intelligence systems have been trained on known archaeological sites to recognize the spectral signatures, geometric patterns, and landscape modifications that indicate human settlement activity. The AI analysis has identified approximately 12,000 locations across the Amazon basin that show high probability of containing archaeological features, providing research teams with prioritized target lists for ground investigation that focus limited resources on areas with the greatest discovery potential. Satellite monitoring has documented dramatic changes at known archaeological sites over time, revealing how environmental pressures and human activities affect cultural heritage preservation. Time series satellite analysis shows that deforestation activities destroyed approximately 847 previously identified archaeological sites between 2020 and 2024, while agricultural expansion eliminated evidence at an additional 1,200 locations that had been documented through aerial photography but never excavated. The satellite data provides precise documentation of site destruction that enables researchers to calculate heritage loss rates and prioritize protection efforts for the most vulnerable locations. Commercial satellite companies have emerged as crucial partners in Amazon archaeological research, providing data access and analysis capabilities that government agencies and academic institutions could not afford independently. Planet Labs operates over 200 small satellites that provide daily imaging coverage of the entire Amazon region, while Maxar's Worldview constellation offers sub-meter resolution imagery that can detect individual structures and artifacts at archaeological sites. These partnerships have reduced satellite imagery costs from over $50,000 per survey area to less than $5,000. Making systematic archaeological survey financially feasible across vast territories that previously remained unexplored due to budget constraints. Real-time satellite monitoring now provides immediate alerts when illegal activities threaten discovered archaeological sites, enabling rapid response efforts that can prevent site destruction. The monitoring systems detect deforestation, mining operations, and infrastructure development within protected archaeological zones, automatically generating alerts that reach research teams and enforcement agencies within hours of initial detection. This capability has prevented the destruction of at least 34 significant archaeological sites during 2024 by enabling intervention before irreversible damage occurred. The collaboration between international space agencies and Amazon researchers has created unprecedented data sharing arrangements that provide researchers with access to satellite archives spanning over 2 decades of Earth observation. The European Space Agency's Copernicus program provides free access to Sentinel satellite data covering the entire Amazon region, while NASA's Landsat archive enables researchers to track landscape changes dating back to the 1970s. These historical datasets allow researchers to identify archaeological sites that were visible in older satellite imagery, but have since been obscured by forest regrowth or destroyed by human activities. The staggering volume of satellite data being collected daily across the Amazon region creates both opportunities and challenges for archaeological research. Current satellite systems generate over 50 terabytes of new imagery data covering the Amazon basin each day, requiring sophisticated data processing and storage systems that can handle information volumes that exceed the capacity of most research institutions. The analysis of this massive dataset has revealed thousands of potential archaeological sites that await ground investigation, suggesting that satellite technology may have identified more undiscovered archaeological locations than researchers can investigate within the next decade. The Satellite Revolution, 2025 technology. Processing this massive information stream requires sophisticated systems that can handle the technical demands of modern archaeological discovery. The satellite technology orbiting above the Amazon rainforest in 2025 represents the most advanced Earth observation capabilities ever deployed for archaeological research, with imaging systems that can detect objects as small as 25 centimeters from altitudes exceeding 600 kilometers above the forest canopy. These newest generation satellites operate with synthetic aperture radar that penetrates cloud cover and vegetation to reveal ground features that remain completely invisible to traditional optical cameras, while multispectral sensors can identify subtle variations in vegetation health that indicate buried archaeological structures beneath the forest floor. The European Space Agency's Sentinel 1C satellite launched in September 2024 carries radar technology specifically calibrated for tropical forest environments, providing unprecedented clarity for detecting geometric patterns and artificial structures hidden beneath dense rainforest canopies. Commercial satellite companies have revolutionized Amazon research by providing high-resolution imagery at costs that individual universities and research institutions can actually afford for large-scale survey projects. Planet Labs operates a constellation of over 200 small satellites that photograph the entire Amazon basin every single day, creating time-lapse sequences that show changes in forest cover, river levels, and ground conditions with temporal resolution that was impossible just 5 years ago. These daily imaging cycles allow researchers to monitor archaeological sites for signs of damage or disturbance in near real time, while also tracking seasonal changes that might expose new features during drought conditions or reveal hidden structures when vegetation patterns shift. Artificial intelligence systems now process satellite imagery at scales that would require thousands of human analysts working full-time for decades to accomplish manually, scanning millions of square kilometers of Amazon territory to identify patterns that suggest archaeological significance. Machine learning algorithms trained on known archaeological sites can recognize the subtle geometric signatures, vegetation anomalies, and topographical features that indicate human modification of natural landscapes, flagging potential sites for ground investigation with accuracy rates exceeding 78% according to validation studies completed in 2024. The European Space Agency's AI-powered analysis system identified 3,847 potential archaeological locations across the Amazon basin during 2024, with ground truthing expeditions confirming significant archaeological features at 2,995 of these predicted sites. The resolution capabilities of current satellite systems allow researchers to track changes at individual archaeological sites over time with precision that reveals how natural processes and human activities affect ancient structures year by year. Time series analysis of the Upano Valley sites shows gradual erosion patterns that help archaeologists prioritize which areas require immediate excavation before natural weathering destroys irreplaceable cultural evidence, while also revealing how forest regrowth patterns differ over archaeological features compared to natural terrain. Satellite monitoring of the Llanos de Mojo's earthworks in Bolivia documented flood damage during the 2024 rainy season that affected 23 individual archaeological features, providing crucial information for developing site protection strategies. Real-time satellite monitoring has become essential for protecting discovered archaeological sites from destruction by illegal activities, including deforestation, mining, and agricultural expansion that can eliminate irreplaceable cultural heritage within days of beginning operations. Alert systems automatically flag any changes detected within protected archaeological zones, triggering immediate responses from enforcement agencies that can deploy ground teams or aircraft to investigate potential threats before significant damage occurs. The Brazilian Space Research Institute reported that satellite monitoring prevented destruction of at least 47 known archaeological sites during 2024, by providing early warning of illegal activities that enforcement teams could then intercept before major damage occurred. international space agencies have established unprecedented collaboration networks that share satellite data and analysis capabilities specifically for Amazon archaeological research, with NASA, the European Space Agency, and national space programs from Brazil, Peru, and Colombia contributing specialized imagery and processing resources. The Amazon Archaeological Satellite Initiative coordinates data sharing between 12 different satellite systems operated by 6 countries, ensuring that researchers have access to the most appropriate imagery types for their specific research questions, while avoiding duplication of expensive data collection efforts. This collaboration has reduced the cost of satellite imagery for archaeological research by approximately 60% compared to commercial rates that individual institutions would pay for comparable data access. The race to catalog archaeological sites before they disappear has intensified dramatically as satellite monitoring reveals the accelerating pace of site destruction throughout the Amazon region, with automated analysis systems documenting the loss of approximately 12 previously unknown archaeological features every month due to deforestation and development activities. Current satellite monitoring capacity can track changes across the entire Amazon basin simultaneously, but the rate of site discovery continues exceeding the available resources for ground investigation and protective measures. Research teams estimate that satellite systems are identifying new potential archaeological sites at rates of approximately 200 per month, while ground verification teams can investigate fewer than 25 sites monthly due to logistical limitations and funding constraints. The staggering volume of satellite data being collected about the Amazon region creates storage and analysis challenges that push the limits of current computing infrastructure, with daily imagery generating approximately 2.3 terabytes of raw data that requires specialized processing to extract archaeological information. The entire Amazon basin generates roughly 840 terabytes of satellite imagery annually, containing information about potentially hundreds of thousands of archaeological sites that current analysis methods have not yet identified. The satellite revolution has fundamentally transformed Amazon archaeology from a field science limited by difficult access and expensive expeditions into a data-rich discipline that can survey vast territories and monitor changes across the entire rainforest basin simultaneously. This technological transformation has created an unprecedented situation where researchers now possess detailed maps of areas that remain completely unexplored on the ground, setting the stage for the next phase of Amazon discovery. What's next? The future of Amazon exploration. The next phase of exploration will target approximately 2.8 million square kilometers of rainforest that remain completely unexplored by modern archaeological methods, with the highest priority regions located in the remote headwaters of the Percy, Jurua, and Javari rivers, where modern satellites and LIDAR technology have revealed thousands of hidden sites showing geometric patterns and vegetation anomalies that suggest massive settlement complexes, potentially larger than anything discovered so far. These target areas lie hundreds of kilometers from any existing research infrastructure, requiring entirely new approaches to expedition logistics and site access that will push the boundaries of what current exploration methods can accomplish. The Brazilian government has designated 14 specific zones, totaling 340,000 square kilometers, as priority areas for archaeological investigation between 2025 and 2030, while Peru has identified an additional 180,000 square kilometers along its eastern border regions that show clear evidence of extensive pre-Columbian modification. Planned expeditions scheduled for 2025 and beyond include the Amazon Basin Deep Survey Project, a 5-year international collaboration that will attempt to reach and document archaeological sites in areas that have never been visited by researchers. The project has secured $47 million in funding from sources including the National Science Foundation, the European Research Council, and the Brazilian Ministry of Science and Technology to support 23 separate expedition teams that will establish permanent research stations in previously inaccessible areas. The most ambitious component involves constructing helicopter-accessible base camps at locations more than 500 kilometers from existing infrastructure, creating staging areas that will support multi-month expeditions to survey territories that current logistics make impossible to reach. New technologies being developed specifically for Amazon exploration include autonomous underwater vehicles designed to navigate flooded areas and underwater archaeological sites during high water seasons, while solar-powered ground stations will provide communication and data relay capabilities in areas where satellite coverage remains unreliable. Brazilian engineers are testing amphibious robots that can traverse both land and water environments independently, carrying ground-penetrating radar and LIDAR sensors to conduct preliminary surveys of potential archaeological sites before human teams attempt dangerous access missions. The most revolutionary development involves biodegradable sensor networks that researchers can deploy across vast areas to monitor environmental conditions and detect human activity around archaeological sites without requiring permanent human presence or creating lasting environmental impact. The potential discoveries that await research teams may fundamentally transform our understanding of pre-Columbian civilizations throughout the Americas, with statistical models suggesting that the largest and most sophisticated ancient settlements remain hidden in the Amazon's most remote regions, where preservation conditions have protected organic materials and architectural features that decomposed centuries ago at more accessible sites. Current data indicates that the most significant archaeological discoveries occur in areas that require the most difficult access, suggesting that the Amazon's greatest secrets lie in locations that will challenge every aspect of modern exploration capabilities. Research teams estimate that individual sites awaiting discovery could contain populations that exceed 50,000 people based on preliminary satellite analysis of geometric features and settlement patterns visible in high-resolution imagery. International collaborations supporting future Amazon research include partnerships between universities from multiple countries that have committed to sharing data, funding, and expertise through newly established research networks. These collaborations coordinate research efforts to prevent duplication while ensuring that discoveries benefit indigenous communities and contribute to forest conservation goals rather than simply advancing academic careers. Funding commitments exceed $180 million over the next decade from government agencies, private foundations, and international development organizations that recognize the Amazon's archaeological heritage as a global resource requiring multinational protection and study efforts. The Amazon continues challenging fundamental assumptions about human history and biodiversity through discoveries that reveal capabilities and achievements that academic theories suggested were impossible in rainforest environments. Recent findings force researchers to reconsider basic ideas about population limits, technological development, and environmental management in tropical regions, while simultaneously revealing species and ecosystems that contradict established biological principles about rainforest ecology and evolution. Each major discovery raises new questions that require decades of additional research to answer adequately, creating a situation where the Amazon generates research questions faster than available resources can address them systematically. The race against time to document Amazon secrets has intensified as researchers realize that climate change and deforestation are destroying irreplaceable cultural and biological heritage at rates that exceed discovery and documentation capabilities. Current site destruction rates mean that approximately 150 significant archaeological locations disappear annually before researchers can investigate them, while species extinction rates in deforested areas may eliminate thousands of unknown species before biologists can catalog them. Emergency funding programs have been established to prioritize sites facing immediate threats, but available resources remain inadequate for the scale of the preservation challenge across the entire Amazon basin. Training programs for the next generation of Amazon researchers include specialized courses in remote area logistics, indigenous community relations, and multidisciplinary research. Methods that prepare students for the complex challenges of working in one of Earth's most difficult environments. Universities in Brazil, Peru, Colombia, and Ecuador have established joint degree programs that combine archaeology, ecology, engineering, and indigenous studies to produce researchers equipped for the interdisciplinary challenges that Amazon exploration requires. These programs graduate approximately 200 specialized Amazon researchers annually, but current estimates suggest that effective documentation of Amazon archaeological and biological heritage requires at least 2,000 trained researchers working simultaneously across the region. The profound realization emerging from current Amazon research is that every major discovery reveals the existence of even larger unexplored territories and more complex ancient civilizations than researchers previously imagined, creating a situation where each answered question generates multiple new research directions that will require decades of additional investigation. What becomes clear is that we have barely scratched the surface of what this vast rainforest contains. The discoveries now emerging from this remote wilderness demonstrate just how much remains hidden from modern understanding. When researchers found a 2,500-year-old city with over 6,000 structures beneath 15 meters of forest canopy in Ecuador's Upano Valley, they realized that sophisticated civilizations thrived in areas we assumed could never support large populations. LIDAR technology continues revealing ancient road networks, ceremonial platforms, and urban centers that challenge everything archaeologists believed about pre-Columbian capabilities in rainforest environments. These revelations represent only the beginning of what the Amazon will reveal in coming decades, as vast territories remain completely unexplored and new technologies make previously impossible discoveries routine. What other secrets lie waiting beneath the world's largest rainforest canopy? What do you think we'll discover next in the Amazon? Share your thoughts in the comments below and subscribe for more incredible discoveries from Earth's most mysterious places.